Imagine something moving so fast that it could circle the entire Earth 7.5 times in just 1 second. Now imagine something moving so fast that it makes that speed look like a snail's pace. Today, we're going on a journey through the fastest things in the entire universe, and by the end of this video, your perception of speed will be completely shattered. Let's start our speed comparison on familiar ground, with the fastest land animal on our planet. The cheetah can reach speeds of up to 120 kilometers per hour in short bursts. That's incredibly fast for a biological creature, allowing it to chase down prey across the African savanna in mere seconds. At this speed, a cheetah covers about 33 meters every second. It's impressive, but we're just getting started. Moving to the skies, the peregrine falcon holds the record as the fastest animal on Earth. When diving to catch prey, this magnificent bird of prey can reach speeds of over 320 kilometers per hour. That's nearly 3 times faster than a cheetah. At this velocity, the falcon experiences forces that would make most creatures pass out, yet it maintains perfect control and precision. The falcon's diving speed translates to about 89 meters per second, making it nature's ultimate speed machine. Now let's shift to human engineering. The fastest commercial bullet trains, like Japan's L0 maglev, can reach speeds of 603 kilometers per hour. This magnetic levitation train essentially floats above the tracks, eliminating friction and allowing for these incredible speeds. At 167 meters per second, you could travel from one city to another faster than most small aircraft. But even this technological marvel is nothing compared to what's coming next. The speed of sound, or Mach 1, sits at approximately 1,227 kilometers per hour at sea level. When aircraft break the sound barrier, they create a sonic boom, a shock wave that announces their passage through the air. Military jets like the SR-71 Blackbird could fly at Mach 3.3, reaching speeds over 3,500 kilometers per hour. At nearly 1,000 meters per second, these aircraft could outrun missiles and cross continents in hours rather than days. But we're still playing in the minor leagues. The fastest human-made object is the Parker Solar Probe, a NASA spacecraft currently studying the Sun. During its closest approaches to our star, it reaches speeds of approximately 700,000 kilometers per hour. That's roughly 194 kilometers per second, or about 0.06% the speed of light. At this speed, you could travel from New York to Tokyo in less than a minute. The probe achieves these incredible velocities by using the Sun's gravity in a series of carefully planned flybys, essentially falling toward the Sun and being whipped around at phenomenal speeds. Now we enter the realm of cosmic speeds. Earth itself is moving through space at about 107,000 kilometers per hour as it orbits the Sun. That's roughly 30 kilometers per second, and you don't even feel it. Our entire solar system is racing around the center of the Milky Way galaxy at an astounding 828,000 kilometers per hour, or 230 kilometers per second. And the Milky Way itself is moving through space at over 2 million kilometers per hour relative to the cosmic microwave background radiation. We're all traveling at incredible speeds right now, just sitting here. Meteorites entering Earth's atmosphere can reach speeds of up to 250,000 kilometers per hour, or about 70 kilometers per second. When these space rocks hit our atmosphere at such velocities, the friction generates enormous heat, creating the brilliant streaks we call shooting stars. The larger ones that survive the journey and impact the surface do so with devastating force, releasing energy equivalent to nuclear weapons. Let's talk about the fastest natural phenomenon we can observe, pulsar jets. Pulsars are rapidly rotating neutron stars that shoot out beams of radiation from their magnetic poles. Some of these jets contain matter moving at 98% the speed of light. That's approximately 294 million meters per second. At these speeds, relativistic effects become significant. Time slows down, mass increases, and the laws of physics as we experience them start to bend. But there's one cosmic speed limit that nothing with mass can break, the speed of light. Light travels at exactly 299,792,458 meters per second in a vacuum, or about 300,000 kilometers per second for simplicity. At this speed, light from the Sun takes just 8 minutes and 20 seconds to reach Earth. Light can circle the Earth 7.5 times in one single second. This speed limit isn't just a universal law, it's woven into the very fabric of space and time itself, as Einstein's theory of relativity revealed. Photons, the particles of light, are born moving at light speed and never slow down in a vacuum. They have no mass, which is why they can achieve this ultimate velocity. Every photon that has ever existed, from the ones leaving distant stars billions of years ago to the ones illuminating your screen right now, has traveled at exactly the same speed. Light from the most distant galaxies we can observe has been traveling through space for over 13 billion years, covering distances so vast that our minds struggle to comprehend them. But here's where things get truly mind-bending. While nothing can move through space faster than light, space itself has no such restriction. During the inflationary period just after the Big Bang, the universe expanded faster than the speed of light. In a fraction of a second, space itself stretched exponentially, taking matter along for the ride. This wasn't matter moving through space at faster than light speeds. It was space itself expanding, carrying everything with it. This cosmic expansion continues today. Distant galaxies are receding from us at speeds that increase with distance. Galaxies beyond a certain distance, about 14 billion light-years away, are moving away from us faster than the speed of light due to the expansion of space itself. This means there are regions of the universe we will never be able to see, no matter how long we wait or how powerful our telescopes become. The light from those regions will never reach us because the space between us and them is expanding faster than light can travel through it. Some theoretical particles called tachyons are hypothesized to move faster than light, but they exist only in mathematical models and have never been observed. If they existed, they would have imaginary mass and could theoretically travel backward in time, creating all sorts of causality paradoxes that would break the laws of physics as we understand them. Quantum entanglement presents another fascinating case. When two particles become entangled, measuring the state of one instantly affects the state of the other, regardless of the distance between them. Einstein called this spooky action at a distance. While the correlation appears instantaneous, this doesn't actually transmit information faster than light, so it doesn't violate relativity. The phenomenon is real and has been experimentally verified countless times, but it cannot be used for faster-than-light communication. Let's consider the speed of gravity. According to general relativity, gravitational waves propagate at exactly the speed of light. When two black holes collide billions of light-years away, the ripples in spacetime they create spread outward at light speed. In 2015, the LIGO Observatory detected these gravitational waves for the first time, confirming Einstein's century-old prediction and opening a new window to observe the universe. The fastest possible speed for any information or causal influence in the universe is the speed of light. This is more than just a speed limit for moving objects. It's a fundamental property of spacetime itself. The speed of light connects space and time in Einstein's famous equation, showing that they're two aspects of the same thing, space-time. This cosmic speed limit ensures that cause always precedes effect and prevents paradoxes that would make the universe logically inconsistent. But even light speed seems slow when we consider the scale of the universe. The Andromeda Galaxy, our nearest large galactic neighbor, is 2.5 million light-years away. Even traveling at light speed, it would take 2.5 million years to get there. The observable universe is about 93 billion light-years in diameter. At light speed, crossing it would take longer than the current age of the universe several times over. This brings us to one of the most profound realizations in cosmology. The universe is expanding, and that expansion is accelerating. Dark energy, a mysterious force that makes up about 68% of the universe's total energy, is pushing space apart at an ever-increasing rate. In the far future, billions of years from now, this acceleration will have pushed distant galaxies so far away and so fast that future astronomers might see a mostly empty sky, with only the galaxies in our local group visible. The evidence of the Big Bang and the broader universe will fade away, leaving a cosmic horizon beyond which nothing can be observed. So what's the absolute fastest thing in the universe? It's not an object or a particle. It's the expansion of space itself during the inflationary period of the early universe, and potentially in distant regions of the cosmos today. Space has no speed limit. It can stretch, compress, and warp in ways that would be impossible for matter. The universe doesn't care about our speed limits. It operates on scales and with mechanisms that challenge everything we think we know about motion and speed. From a cheetah sprinting across the savannah at 120 kilometers per hour to the expansion of the universe itself operating beyond any comprehensible speed, we've journeyed through the entire spectrum of velocity. Each level of speed reveals something profound about the nature of reality, from the biological limits of life to the engineering triumphs of humanity, to the fundamental structure of space-time itself. Speed isn't just about how fast something moves. It's about the very fabric of existence and the laws that govern our universe. The next time you see a shooting star or watch light stream through your window, remember, you're witnessing the universe operating at speeds that connect the smallest moments to the largest cosmic scales.